All right. Well, good afternoon, everyone, and thanks for being here today for the Student Research and Innovation Showcase, hosted as part of the WiSys 2021 Spark Virtual Series. I'm Jennifer Souter, WiSys's Director of Patents and Licensing. For those of you not familiar with WiSys, we're a nonprofit supporting organization of the UW system. And at WiSys, we support research, we protect and market ideas, we inspire students, and we build culture, all with the goal of inspiring Wisconsin innovation. On behalf of WiSys, we are delighted for a second week in a row to be able to feature UW System student researchers and innovators as part of this live broadcast. Today, you're going to be hearing from 9 student groups from a variety of academic disciplines and UW campuses. Today's presentations will be scored by a judging panel, and our presenting students will have the opportunity to earn cash awards for their efforts. Speaking of judges, I would like to take this opportunity to welcome our judging panel for today's event. I'd like to first welcome Tracy Davidson, Director of STEM and Applied Research Initiatives at UW System Administration. Tracy, you're most welcome. Thank you. From WiSys, please welcome Adira Sankara, our Manager of Innovative Ventures. Thanks, Adira. And last but not least, Dr. Elizabeth Glugowski from UW-Eau Claire and co-chair of the 2021 Spark Symposium. Thanks, Liz. So today's first place winner will take home a cash prize of $1,000. Today's second place winner will take home a cash prize of $500. I'd like to now take this opportunity to thank our prize sponsors and longstanding partners at the Wisconsin Alumni Research Foundation and Boyle Frederickson Intellectual Property Law. We are grateful for your ongoing support. In addition to today's top prizes, all students taking part in this series of the student showcases will also be competing for the Tim Higgins Award for Commercial Relevance, which will be announced during the August showcase later this summer. Today's winners, however, will be announced at the conclusion of today's event. So in just a few moments, each presenter will be introduced and cued to start their presentation. Before we get started, I have a few notes of housekeeping. To get the most out of your viewing experience today, we encourage you to use speaker view and ask that you please leave your audio and video turned off during the main presentations. During each presentation, we ask that you submit questions to the chat log, and we will address those questions at the end of each student's presentation via moderated chat. The judging panel will also have the opportunity to ask 1 to 2 questions of each presenter. Following the first 5 student presentations, we'll be breaking out into a breakout session for networking and further Q&A with Group 1 presenters. All attendees will have the option to choose whether they would like to attend the breakout room for STEM or social sciences and humanities. You will receive a notification once the rooms are open, and you can join the rooms by clicking on the breakout room icon located in the bottom ribbon of your Zoom screen. At the conclusion of the second group of presentations, we will also continue with the same breakout format to allow the judges to deliberate and to also have additional Q&A with Group 2 presenters. We'll then reconvene back in the main room at the conclusion for closing remarks and to announce the winners of today's event. Now, without further ado, I'm delighted to introduce our first group of presenters. Please join me in welcoming our first student presenter, Sarah Albers from UW-River Falls. Sarah?
Hi everyone, good afternoon. I'm Sarah Albers, as she mentioned, and today I'll be presenting on the effect of secondary iron injection to suckling pigs on growth performance and hematocrit level in the suckling period. As she mentioned, I'm from UW-River Falls, and I'm an animal science major with a meat animal emphasis. Next slide. So anemia is a very common problem in the pork industry. So providing an additional iron injection at birth is a common practice amongst pretty much every producer in the US and across the globe. A single iron injection has been proven by many studies to be not adequate for those piglets who are weaned after 21 days postpartum. The weaning process is where the piglets are removed from the sow and transition from a primary liquid diet to a primary solid diet. Since this has been proven to not be adequate, it can be assumed that piglets weaned after 21 days of age may need an additional iron source. That secondary iron injection before weaning may help boost those pigs' iron status if given to them close before weaning. The objective of our study was to evaluate the effects of secondary iron dextran injection on piglet growth performance as well as hematocrit level during the suckling stage. We also were trying to demonstrate an optimal dose of the second iron injection for the suckling piglets. This is where our 2-part trial came in, and today I'm just presenting on the first part of the 2-part series. Next slide. For our experimental design, we had 4 litters at 11 days before weaning, which was 16 days of age. Those litters varied in size from 9 to 11 piglets with an average of 10.25 pigs. Each of the piglets had previously received their primary iron dextran injection of 200 milligrams at day 1 of age. At the time of that injection, they were also processed, which is when all of the piglets in the litters had their ears notched for identification purposes and their tails docked, which is another common practice in the swine industry. The males in the groups were castrated, and the females of the purebred litters also had their functional teats counted. The piglets were then allotted into 3 treatments within litter, which had 8 piglets per treatment. These were based on body weight and gender. And as a general description, we then weaned at 27 days of age. For our treatment groups, we had a control of no additional iron injection after the first injection, an iron 100 group, which had 100 milligrams of iron dextran injection 11 days before weaning for their secondary injection, and then iron 200, which had 200 milligrams of iron dextran injected 11 days before weaning for their secondary iron injection. We collected our blood samples for hematocrits on days 11, 7, and 4 days before and the day of weaning for our collections. We also took body weights on those days as well. And our daily rate of gain was taken on an individual basis. On the left, you'll see myself and then my roommate helped working on doing our blood collections. I was taking a jugular blood collection because that's a very accessible area and less stressful scenario for the piglets. As you can see, we used a V-gate, and my roommate was the one helping me restrain the piglets so that we could get them to be as calm as possible for the procedure. On the right, you'll see myself analyzing my hematocrit levels. And after I would look at them, my roommate would then also do a double variant just to make sure that we were looking at the same values for everything. Next slide. For results, for our hematocrit levels, we did have an increase in both of the 100 and 200 milligram treatments of iron injection from day 7, the interval from 0 to 7, and day 0 to 11 post-injection. On day 11 post-injection, the 200 milligram had a higher hematocrit level than the 100 milligram level, but it wasn't continued throughout the others. And then we had day 7 to 11 interval, the 200 milligram treatment also increased the hematocrit level, which none of the other treatments did. For our growth measures, we did not find any significant differences in our growth performance in the suckling period, which is why even though we did have a second trial in this 2-part series, we are looking to do further studies to make sure that we can continue that, the growth measures to see what effects would come in the long term. Next slide. So as a conclusion, we found that the secondary iron injection did not affect the pre-weaning growth performance, and the additional iron injection did increase the hematocrit levels. With the 200 milligram treatment, it was slightly higher than the 100 milligram, which is why we had further studies to try and dial in on the optimal dosage for the iron. As I mentioned, we would like to follow our future studies into the nursery period to see what the post-weaning applications of this secondary iron injection would lead to, because we aren't quite sure of that right now, and not many of the previous studies we've looked at have followed them through to that stage. So it'd be something that we're going to try for in the fall. Next slide. And I would like to take this time to thank the Man Valley Lab Farm for allowing our project to occur during the COVID-19 pandemic. We had a lot of adjustments made and a lot of extra protocols, so we were very appreciative of that. And for the UW River Falls Office for Undergraduate Research, Scholarly, and Creative Activity for funding the project. And last but certainly not least, Dr. Jang for his guidance and leadership along the way. It was a lot of coordinating, as I mentioned, through the COVID policies and very limited contact, but we were able to properly learn procedures and make sure that all of our animals were helped very well, or taken care of very well during this time. So thank you.
Thanks, Sarah. That's great. Can I ask our judges to come online and if they have any questions for Sarah?
Hi there. I have a question. I don't mind. I'm wondering, you mentioned that it's a common problem that there's anemia, and I'm wondering why that's a problem. I mean, what sort of fallout is there from piglets having anemia?
So from the kind of a little backstory for this one, when we started transitioning from outdoor housing to indoor housing, the natural ethos of the pig is to root around in the soil. And while they would go around in the soil, they'd be picking up iron. And now that we have transitioned to mostly confined housing in our swine industry in the US, the sows just aren't consuming enough iron to be able to have it translate into their or into their milk in high enough quantities to keep their piglets healthy. When the piglets become anemic, they just become very skinny and dehydrated and aren't as productive as what they should be. What we're really looking for in a good litter is that we have a solid group that's very strong and healthy throughout their entire suckling stage before we wean them, because the weaning event is very stressful on all mammalian species. As any mother may know, it's not a very pleasant time to go through. So we want to make sure that they're as healthy going into that period as possible. And if we can prevent the anemia, then we're hoping that we can get them a better start into the nursery period.
Great, thank you.
Answer your question? Okay.
Maybe one more question from the judges.
I have a question. So you said for the second injection, it's either 100 milligrams or 200 milligrams. Is that true for the first injection too? Did you do both?
For our first injection, we had to do 200 milligrams across the board. Since that's been the proven number, well, actually the dosage is technically 100 is required, but our farm's protocol is to have 200 milligrams. So we gave everybody their primary injection of 200 milligrams of iron. And that way they were all assumed to be at the same hematocrit levels, or so that going into the study. So we kind of had pushed back to try and limit our collection days with COVID, so that way we could make sure that everybody was at the same status prior to getting farther into the study. And it cut out 2 collection days that we did end up having in our second trial once we were able to have a few more COVID policies lifted and have more exposure to other handlers.
Thank you.
All right. Well, thank you so much, Sarah, and thank you, judges.
Thank you.
All right. Next up, we have Becca Burell from UW-Oshkosh. Becca?
Good afternoon. My name is Becca Burell, and my pronouns are she, her, and hers. I am a nursing student at UWO and a member of and advocate for the LGBTQ+ community. Today, I will be presenting on understanding LGBTQ+ healthcare best practice methods in Wisconsin's Fox Valley area clinics. Next slide, please. In recent years, the medical profession has begun to address the unique needs and disparities of the LGBTQ+ community. Despite recognizing these needs, though, there continues to be a lack of clinics following best practice recommendations for care of the LGBTQ+ patient. While many organizations have determined best practice methods for clinics and providers to implement, they have not analyzed the extent to which clinics are applying these methods. Currently, only 3 clinics are recognized as providing culturally affirming healthcare in Wisconsin, none of which are found in the Fox Valley region. The lack of known clinics providing culturally competent healthcare led to the development of my research question. Next slide. The purpose of my inquiry was to identify what LGBTQ+ healthcare best practice methods are clinics in Wisconsin's Fox Valley area applying to their practice, and how can these methods be improved to decrease healthcare discrepancies. Specifically, do clinics offer LGBTQ+ services, and are there intake forms, clinic environments following best practice guidelines? I hypothesized that since none of the 3 clinics providing culturally affirming healthcare are found in the Fox Valley region, that clinics would be struggling to develop and implement culturally affirming healthcare. Next slide. To explore my research question, a 26-question online Qualtrics survey was developed and sent out via email to providers practicing in the Fox Valley region and contained questions about the 3 domains that shape an individual's experience in healthcare: the clinic environment, intake forms, and specific LGBTQ+ services offered. These domains reflect an LGBTQ+ person's first impression and experience in a clinic that will determine their outlook on the healthcare industry as a whole, and if they will continue to seek care for current and future health needs. In addition to compiling data on the clinic's practices, providers were offered the opportunity to receive a packet of information containing current LGBTQ+ healthcare best practice methods. This information was essential to offer because in order for clinics to advocate for change, they need to be informed on current best practice methods to fit the needs of the community. Next slide. In the first section of the survey, providers were asked about their clinic environment, which included LGBTQ+ visual cues, their non-discrimination statement, and gender-neutral bathrooms. As you can see from the results on the slide, clinics fell short in one major area: a lack of visual cues in their waiting area. Only one clinic provided visual cues, such as posting a rainbow flag or exhibiting posters and brochures showing racially and ethnically diverse LGBTQ+ people. While some may view these as small, insignificant signs, LGBTQ+ individuals look for these subtle indications that they are at a welcoming clinic that will be able to provide them with competent care. In addition, this visible evidence may decrease the stress and anxiety of patients, which will in turn encourage them to disclose their orientation and identity to the provider. Next slide. Next, providers were asked about their intake forms. Overall, the first bar graph indicates that clinics are beginning to use LGBTQ+ inclusive language and identification measures on their intake form, which sets a positive tone for the patient's visit and provides them with a safe space to disclose their identity. Beyond this, though, clinics again lack in 2 other parts of their intake forms. Unfortunately, none of the clinics in the Fox Valley region utilize a disclosure statement or an explanation about why they are being asked certain questions, which may leave patients hesitant to answer various questions on the intake form for fear of discrimination or being outed. In addition, clinics that ask about breast health or reproductive anatomy need to remove binary methods of asking, such as saying for men only or for women only, and instead include an organ inventory or fill in the blank section to be inclusive of all gender identities and orientations. Next slide. Finally, I asked about specific LGBTQ+ services or screenings that clinics offer regarding sexual health, mental health, and trans-affirming therapy. Overall, most clinics are providing essential sexual and mental health screenings to their patients. Clinics will continue to perform well in these 2 categories as long as providers remember to 1, never assume cisgender heteronormative stereotypes regarding one's sexual health, and 2, address the root cause of any mental health problems without blaming someone's sexual and/or gender identity for the disease. As you can see in the graph, one area that clinics are lacking is providing gender-affirming treatment or hormone therapy, since only 4 clinics in the Fox Valley region indicated that they offer these services. Clinics in the area require education on how to provide transgender-affirming healthcare treatment. Next slide. All in all, in order to decrease LGBTQ+ health disparities, clinics and clinicians need to offer a structural and interpersonal safe space for community members. Through this research, providers now understand where the Fox Valley region is falling short regarding LGBTQ+ healthcare and can educate themselves on current best practice methods. With this knowledge, healthcare providers can advocate for change to their current practice methods at their clinic in order to create a safe and welcoming environment for community members. Provider advocacy and Fox Valley clinics will work to increase LGBTQ+ individuals' access to local, culturally affirming healthcare and decrease LGBTQ+ healthcare discrepancies in our community. Thank you.
Thank you, Becca. I think we have time for one question from the judges.
Hi, Becca. That was a great presentation. Thank you for your work on this. I was wondering if at any point during your research, you've also reached out to the LGBTQ+ individuals to get their perspectives on sort of the level of healthcare that they have received at some of these clinics. I know that's a little bit trickier with IRB approvals and, confidentiality issues, but is that in the works at all?
It was not officially through the actual work that I did, but I was president of the LGBTQ+ organization on campus. So through talking to different people in that organization and everything, I was able to get an understanding of what sort of healthcare people were receiving. And I think that the best place that people were finding that they received affirming healthcare was actually on campus at the clinic on campus, because we had a good provider there. But beyond that, a lot of people found similar things where they were struggling to go out into the community and actually be able to find a provider that could provide them with the necessary care.
Great, thank you.
All right, thank you, Becca. All right, next up, we have Megan Bunyer from UW-Platteville. Megan?
Hi, my name is Megan Bunyer and my partner's name is Courtney Shane. We collaborated on this project under the guidance of our faculty mentor, Dr. Corey Enright. We were generally interested in the student learning experience. We both decided it would be a very relevant topic to study in relation to the online learning experience, as circumstances surrounding COVID-19 have led to an influx of online learning. So we decided that 3 factors, learning style preference, perceived teaching style, and motivation, would be particularly relevant to the current climate. We named our project the Association Between Student Learning Style Preference, Perceived Teaching Style, and Motivation in Online Learning. Next. Okay, so in transitioning online, roughly 14 million students had to go through this. These are students who would have selected to learn in an in-class setting. They were sort of faced with a situation which they had no choice but to take online classes. Approximately 43% of students reported never having taken an online course previously. And some recent research has even found that students have experienced downward shifts in motivation during this time. In our research, we found significant knowledge gaps in the existing literature surrounding online learning. Professors were unprepared to deliver courses online. They had little previous training. Many had questions surrounding a variety of factors, like how can they be inclusive? How can they adapt their curricula to accommodate all students? How can they improve students' course enjoyment? And how can they engage students? Even more, how can they get students motivated just generally when these students didn't want to take online classes in the first place? So we found that learning style preference, perceived teaching style, and motivation are aspects of the student learning experience that might assist professors in answering these kinds of questions. Previous research has found that matched learning and teaching styles increase course enjoyment and even academic performance, whereas divergent learning and teaching styles decrease course enjoyment. We also found that relevant to motivation, intrinsic motivation, as well as self-efficacy, may significantly influence the student learning experience in an online modality. So our hypotheses, students, yeah, go ahead, next slide, sorry. Students' learning style preference would more closely match their professor's perceived teaching style in their favorite versus least favorite class. And students would display higher levels of course-related motivation and self-efficacy in their favorite versus least favorite class. We predicted overall students would display higher levels of intrinsic motivation and self-efficacy in their favorite versus least favorite class. So as you can see on the slide, participants, we had 128, 79 were males, 49 females, 96% were white. There was a mean GPA of 2.75. And in the diagram there, the pie chart, you can see the participant online enrollment for the fall of 2020 semester. 39% of students took 5 or more online classes, 34% took 4, and so on as it descends. We used an independent group's multivariate design. So just to clarify, our dependent variables were perceived teaching style, learning style preference, motivation, and GPA. Our quasi-independent variables were favorite versus least favorite class and demographics. Students were randomly assigned to each class condition. 117 survey questions were included in total, in addition to a demographic questionnaire through the Qualtrics survey platform. And quickly to go over the measures that we used the Grasha-Reichman Student Learning Style Scale to measure student learning style preference. There were 6 categories. So we have the independent learning style preference. Students prefer to learn on their own. Dependent learners prefer to kind of be told what to do. They learn that way. The competitive learners like competing with other students. The collaborative learners like to work with other students. Avoidant learners, they don't like showing up to class. And the participant learners like obviously participating in class activities. We also used the Grasha-Reichman teaching style inventory, which had 5 categories. The expert is seen as being knowledgeable. The formal authority is seen as being removed and structured. The personal model is seen as being demonstrative. The facilitator is seen as someone who guides students to arrive at their own conclusions, and the delegator is seen as someone who likes to do things such as assign tasks. And the last measure we used measured intrinsic and extrinsic motivation and self-efficacy, and that's called the Motivated Strategies for Learning questionnaire. Next slide. So just a little bit about our results. As you can see, if you can see there, our correlational analyses, we ran 2 sets for favorite versus least favorite class. In students' favorite class, we found that avoidant learners were more likely to prefer or perceive their teachers as being delegators. Collaborative learners were more likely to perceive their teachers as being a personal model and facilitator, and competitive learners were less likely to perceive their teachers as being delegator. In the least favorite class condition, independent learners were less likely to perceive their professors as being a delegator, and collaborative learners were more likely to perceive their professors as being a delegator. Next slide. So for future research, we would recommend examining course-specific grade, additional factors like growth mindset, measures of professors' levels of experience with online learning, and having a more diverse participant pool to more accurately capture the student learning experience in an online modality. To conclude, we believe that certain methods of instruction may be limited due to the modality. The online modality, like the personal model teaching style, for example, might be harder to incorporate because it involves demonstrative techniques. Matching some learning style preferences with teaching styles might be beneficial in online learning. For example, we found that the facilitator teaching style was predominantly preferred in classes students enjoyed. And this might even be beneficial despite course modality, as predominantly preferred facilitator teaching styles are commonly found in in-class learning environments. Lastly, similar to the common finding of the predominantly preferred facilitator teaching style, students might be more intrinsically motivated in classes that they prefer despite course modality, and regardless of whether they choose to learn online, because students who select the online format have also been found to be more intrinsically motivated in classes that they enjoy. Next slide. And I'd just like to take this moment to thank Dr. Corey Enright, our faculty mentor.
Great, thank you, Megan. I think we have time for just one question from the judges.
I have a quick question, I think. So you talked about the number of online classes, but did you look at the percent online classes? I'm just wondering if students took fewer classes, or if, you know, when they had 2 online classes, that meant the other classes were in person or hybrid or something.
No, they were all online classes, so it was more just a measure of like if they took 5 or more, the percentage of students who were overall taking online classes took 5 or more. For 4 classes, like 34% took 4 classes, and then it kind of descends from there. Does that make any sense?
Yeah, but I guess I'm asking if the students who took 2 classes online, were those the only classes they were taking?
Oh, okay. Sorry, I missed that. I don't know. That's a really good point. Thank you.
Thanks.
All right, great. Well, thank you, Megan.
Thank you.
All right, next up we have a group presentation from Mikelia, Heberer, Esther, Jeninga, and Peyton Sanders from UW-Whitewater.
Hi, our project is called Experimental Replication of Factors Causing Landslides Along the Lake Michigan Shoreline in a Laboratory Setting Using a Multimodal Device. Our presenters are Esther, Jeninga, Mikelia, Herbert, and Peyton Sanders. Our mentors that helped with this project are Juk Bhattacharya, Asghar Yavusetin, and Haijin Sun. We also had contributions from Brett Steck. Advanced slide, please.
For this project, our main focus was on replicating the erosional process along the Lake Michigan shoreline. Being a multi-field project, this presentation focuses almost exclusively on the physical application of the project. The second half of this project was technology-based, which utilized computers and sensors created by the Physics and Computer Science Department. Erosion along the Lake Michigan shoreline tends to increase during springtime, potentially leading to landslides. This can be caused by moisture content percolating through the material, which might create weakness. As seen in the picture on the slide, landslides on Lake Michigan are a serious problem that needs to be addressed. Advanced slide, please.
For this project, we used a Raspberry Pi. The Raspberry Pi stores the data that can be used in graphs. Parts of the Raspberry Pi includes 4 soil moisture sensors and 4 temperature sensors. When deciding how to set up our experiment, we had to take into account several variables looking specifically at real-life applications. Such variables include the water level of the lake, porosity of the soil, different layers within the soil, average temperature, and the average moisture content, which can be affected by rain and snowfall. To replicate these variables in the experiment, we use different water levels in our experiment container for the erosional process, and sand as the dominant material around the shorelines. We created different layers of saturated and unsaturated sand, along with a layer of ice to replicate the changes in seasons. Unfortunately, we were unable to replicate the average temperature inside the lab. Advanced slide, please.
The supplies that we used were sand, which was purchased from Sandtastic, a storage bin that could hold the experiment, a tin pan to form our base layer and to be the foundation of our model, a scale to weigh the sand and water ratios, liquid nitrogen to quickly freeze the layer of water to form ice, saran wrap to wrap the sand cliff so water didn't trickle outside of the model and of the experiment, and deionized water for our makeshift lake and different saturation levels. To start our experiment, we filled the plastic container with 2.5 centimeters of water. This was to mimic the natural erosion process that takes place on the shoreline of Lake Michigan. Because of the erosion from the standing water at the base of the experiment, the sand became unsteady, thus causing a landslide. Next, we oversaturated the sand at the bottom of our makeshift cliff because that represents the area that is closest to Lake Michigan. The second layer represents the process in which the moisture moves from a saturated zone to an unsaturated zone. The third layer is used to depict the accumulation of water during winter. The ice layer, layer 4, represents frozen ground during winter, which will add to the water table as the ice melts. Finally, the fifth layer was oversaturated with water. This was so that we could see the moisture travel through the layers, which would eventually increase the lake level. Advanced slide, please.
When it came time to testing our model, we played around with different layering. We measured the sand layers by weight rather than height because we would not be able to account for sand's tendency to compact. This compaction would cause a shift in height and would disrupt our measurements. Once we decided on the appropriate layers, we ran the experiment several times to confirm that we would make a slide occur. One more click, please. There's a transition. Yeah, there it is. After establishing consistent erosion patterns, such as crack formations, the picture on the left, the undercutting, the picture on the right, we began implementing moisture sensors to track the motion of water through the soil. This allowed us to predict where the slope failure would occur. Advanced slide, please.
As our experiments progress, we plan to alter several variables to better represent the shores of Lake Michigan. Regarding the material we use for our cliff, we are considering including clay layers within the sand, which would provide an impermeable surface so water would flow horizontally rather than vertically. Another idea we have is to change the material to playground sand, which contains a variety of different grain sizes. This would change the permeability of the sand, which may alter the occurrence of slope failure and better represents real-life situations. In addition, we will begin using a strain gauge to more accurately track the movement of material as it separates from the cliff. We also want to use the moisture sensors more consistently and accurately measure the weight of each layer to better understand the effects that temperatures and moisture content have on slope failure. Lastly, we hope to begin field testing soon this summer to see how our theories and equipment work in the real field. Thank you.
All right, great. Thank you so much. I think we have time for 1 to 2 questions from the judges.
Hey, I have one question. I'm really curious. So how does it work in the field then? Because it's really interesting. It was really interesting to see your methodology there, and you have the small sort of contained space. How would that work in the field? Would you just have probes that were just much more spread out, or how would this apply then? How would this method apply to see what's going on?
Yeah, so in the field, we plan right now to go check out different areas. We don't want to go and put random probes everywhere and people's lawns and stuff like that. So it's something we got to coordinate with homeowners and county representatives and all that. But something that we could go do now is go examine an eroded area along the shoreline versus a non-eroded area, and kind of bring that information back to our lab setting and kind of try and replicate it.
Interesting. So would you in the applied real life setting, would you use the probe? I mean, would you use that and you just have to just scale up on where the probes go?
Right.
Is that how?
Right.
Yeah. Okay. Interesting. Thank
yeah.
you.
Yeah, no problem.
Any other questions from the judges?
Yeah, I had a question. I thought it was interesting that you used deionized water for replicating your lake. Do you think that the sort of the movement and the waves in the lake and the mineral content of the lake itself could be affecting some of these landslides?
I don't think that the content of the water itself could cause the landslides. Mainly, it's just the water hitting the surface. Mikelia, do you want to take over on why we use the deionized water?
Sure. So the whole reason why we had the deionized water in the first place was, as a control in the experiment. That's that's a really good question regarding if like different like minerals inside the lake actually affect it. My first I guess would be, I don't think so, not really too much, unless it's like eating away at like, say, like limestone or something. Then that would play like a big role. But we mainly focused, the first phase of this project was mainly looking at like the freeze thaw cycle that is very consistent on Lake Michigan. You have, water that percolates down into cracks and then it freezes, which, expands the crack. And then you have this constant repeated process. It's just a vicious, endless cycle. And you have houses that have been sitting, on the shoreline for 30 plus years. And all of a sudden they look out their back window and their whole backyard's gone, So the main idea of this project was mainly to, look at different ways in order to like predict a landslide. We're not looking to like manage landslides. The first goal is really being able to take these different processes that we've developed in order to make a reasonable series of events leading to predicting landslides. So, yeah.
Great. All right, thank you very much, Mikelia, Esther, and Peyton. All right, our last presenter for this first group is Jason Martin from UW-La Crosse. Jason?
Yep. All right, am I good to go? Can you hear me?
Yes, you're good to go.
Okay, sorry. Yeah, so hello everyone. My name is Jason Martin. I'm currently a senior studying chemistry at the University of Wisconsin-La Crosse. And today I'm going to be talking about control of texture and morphology of zinc films through pulse methods from additive-free electrolytes. Next slide, please. Beginning with applications of zinc coatings, zinc is a versatile metal that has applications in preventing the corrosion of iron and steel parts, catalysis, such as the electrochemical reduction of carbon dioxide, and an energy storage via a zinc-based battery. The primary reason for its exploration is that it's relatively inexpensive, as well as it's less environmentally harmful than a lot of the previously used metals. An example of that would be like a lithium in a traditional lithium-ion battery. Now, if I can place your attention to the image in the middle of the screen, when zinc crystallizes, it has a variety of orientations that it can grow in. These are also known as textures. And depending on the overall texture of the zinc coating, it will have altered characteristics for any given application. For instance, theoretical studies have indicated that the 002 texture has greater corrosion resistant properties, whereas the 101 texture has better catalytic properties. As a result of this, previous studies in zinc have isolated ways to select for specific textures. But the main issue is that they used a lot of organic additives, such as polymers and surfactants, to achieve these effects. And a lot of these effects are not desired as, additives are not desired as they can be expensive. They can become incorporated into the deposit, weakening it overall, and they have potentially negative environmental runoff. Therefore, we sought to achieve the same level of texture control as previously found, but without all the convoluting effects of additives. Next slide. So moving into our experimental design, as seen with the image on the left half, we utilize an industrially scalable parallel plate flow cell to perform our zinc film plating. Our setup included a flow controller to maintain a stable level of zinc solution in the cell, as well as an electricity source that supplied an adjustable pulse current. In the schematic of applied current versus time on the top right, pulse current differs from traditionally used direct current as it introduces pulsed amounts of current rather than a steady current. And the total amount of current and the length of each pulse can be controlled by altering the time on and the time off variables. So in our study, the 4 experimental parameters that had the greatest effect on texture selectivity were the overall peak current density, the duty cycle, which is a ratio of time on to time off, and the most important one is the absence of additives in our bath composition. Next slide. To characterize the zinc films we produced, we utilized scanning electron microscopy and X-ray diffraction. Starting with SEM and going from right to left, a very noticeable shift from hexagonal clusters to more needle-shaped deposits was observed as a function of increasing peak current densities. The intermediate peak current density of 0.125 amp per centimeter squared, as shown by the image in the middle, supports that there is a gradual trend in change as it displays both hexagonal and needle-like characteristics. There's also a decrease in the average particle size as the hexagonal clusters present in the low peak current density sample are much larger than those of the needle deposits in the higher peak current density sample. So a more quantitative approach to characterizing the texture of our zinc films involved X-ray diffraction. And X-ray diffraction consists of shooting X-rays at your sample and measuring the angle and intensity of which it diffracts off. And from this, we were able to determine that there was a preferential shift from the 002 texture to the 101 texture as a function of increasing current density. This can be seen in the image in the bottom left, where the relative intensity of the 002 peak is much greater than the 101 peak at that low current density. But at the high current density, the 101 peak current is the relative intensity of that peak current is much greater than the 002 peak current intensity. Another thing we were able to do with XRD values is we were able to calculate that the average grain size of the deposit decreased from 33 nanometers to 19 nanometers as we increased that current density from 0.032 amps to 2 amps per centimeter squared. Next slide, please. To conclude my presentation, I'm just going to go over the main takeaways as well as some of our future work. Firstly, we demonstrated that we could control the texture and grain size of zinc deposits through pulse methods, and this was performed in the absence of organic additives that were previously used. And by getting rid of those additives, it makes our method cheaper, more sustainable, and environmentally friendly. Going forward, we'd like to further test to see if the 002 texture does have better corrosion resistance properties, and if the 101 texture has better catalytic properties by utilizing it in the electrochemical reduction of carbon dioxide. Next slide, please. Finally, I would just like to thank my entire research group for their contributions, as well as the University of Wisconsin-La Crosse and WiSys for helping fund our research. Also, if you're interested in learning more about the technical aspects of our findings, I've included a screenshot of our published paper, as well as the included reference below. Thank you.
Great, thanks, Jason. I think we have a time for 1 to 2 questions from the judges.
I have a question. I'm trying to unmute. Sorry.
Yep, you're good.
Yeah, that was interesting. So the pulsed technology, what else is out there to try? So this is basically you're trying to customize the zinc texture. This is a good first step, and what you're showing is that you can change the zinc texture based on changing the characteristics of this pulse, right?
Yep.
What else, do you have any idea what else is out there to try and do it without additives? What might be another way, something else that could be tried?
Yeah, so there's a variety of electroplating, or that's also called electrodeposition. They're interchangeable, but we're utilizing a parallel plate flow cell, which is just two electrodes separated by electrolyte. There's also cyclic voltammetry, which you apply a potential over you apply like a various potential, which is a little different. That's voltage, whereas we're using current. And then we use pulse deposition, which is, again, you're doing pulses of current. There's also direct current, which is a more traditional approach, where it's just you turn your current on and let it run for a total amount of time.
Are you going to try some of those other techniques, do you think, in the future, or is it pretty technical to stick with the technique that you're using now?
Yeah, so we're probably going to stick with the pulsed current as opposed to direct current, because with pulse current, it has a lot more control. Electrochemistry in general is very hard to separate, like phenomena versus it's hard to separate cause and correlation. So by using pulse deposition, it allows us to have more control over the actual electrodeposition process.
Thank you.
Any final questions?
Yeah, I had a question for Jason. So this is really cool, but what do you think about the scalability of this technology? Like, are you doing this on the bench top, you know, on your lab bench with what, an inch, a couple of inches in terms of the surface area? You know, how do you, can you scale this? Like, can you do this on a larger scale from a manufacturing perspective?
Yeah, so part of the reason we use this flow cell is it doesn't require a reference electrode. So you can literally just take your anode and your cathode and stick them on two metal sheets, and it should work that way. But we actually used is a 2.5 centimeter squared surface area. And there's no reason why you wouldn't be able to take that cell and just make it larger so you can get maybe, 100 square centimeters, 200 square centimeters.
Great, thank you.
All right, great. Well, thank you, Jason. All right, I think we're all coming back. Give everybody a few minutes to get back into the main room. All right, perfect. Well, without further ado, I am pleased to introduce our second group of presenters. And I'd like to please welcome our first presenter, Michelle Meyer from UW-Milwaukee. So Michelle, take it away.
Hi there, I'm Michelle Meyer. This is me in the picture. I am a recent graduate of UW-Milwaukee. I work in the Arnold Group. To introduce my topic, I will present on the basics of drug discovery. In creating a drug candidate, a particular target must be identified within a biological function. This target should be anticipated to have a therapeutic effect if influenced. Next, you screen for hit compounds. Hit compounds demonstrate a specific activity to the target. Lead optimization takes the hit to lead compound to then aim to improve effectiveness, limit toxicity, and to increase target metabolism. Advanced slide. I now introduce the overall pathway to drug development. As mentioned in the previous slide, drug discovery provides lead drug candidates to be tested in preclinical studies. This is the basics of my studies. I primarily focus in this presentation the preclinical side. The basics of the preclinical stage is drug metabolism and pharmacokinetics, otherwise known as DMPK, pharmacology, and toxicology. Compounds that pass this stage will be submitted for review before entering the clinical stage and thereafter pharmacovigilance. This is just long-term study. Advanced slide, please. To start, I use a cytotoxicity assay to help determine the lethal dose of a given compound. This is a preclinical assay under the realm of toxicology. It works as a luminescence-based cell viability assay. Essentially, I just plate cells that will be introduced to a compound at various concentrations. After incubation with the compound, I use cell titer glow and add it to each well. The cell titer glow substrate will use ATP to mediate a reaction in live cells to produce light. This light is read on a plate reader to produce the data. Looking at the graph, we see the luminescence versus the log concentration in terms of micromolar. Those with a high LD50 reading means that the higher concentration of the compound is required to kill 50% of the cells. Those with the lower LD50 reading, like the FRI72, the second in the list, require less concentration to kill 50% of the cells. Compounds like this would likely stop being investigated because it's considered toxicity. Advanced slide, please. After the cytotoxicity assay has determined that the compound is non-toxic, this compound can be tested in vivo in a rod assay. I perform this assay on rod trained mice. Trained mice are able to walk on a rod moving at a constant velocity for 3 minutes straight. This apparatus is shown on the bottom left, except in this case, the mouse is falling. The compounds are administered via oral gavage at a concentration of 40 milligrams per kilogram. The mice are tested on the rod at time points of 10, 30, and 60 minutes after administration. This assay examines the overall sedation and motor coordination of the mice under the compound. The data on the right shows 2 non-sedative compounds compared to the vehicle and a known sedative diaphragm. A sedative compound causes the mouse to fall more, producing data as shown on the left. Advanced slide, please. In conjunction to the rotarod, I perform an open field assay. This assay scores the behavior of the mouse while still being subjected to the compound. This apparatus is shown on the bottom left. It depicts a mouse being recorded in an enclosure. This video is then processed using a program called EthoWatcher. This program records data on the speed, location, duration of the mouse during the time of the video. This data is then processed into graphs as shown to the right. Here we see a mouse treated with the vehicle and a mouse treated with caffeine. The mouse treated with the caffeine has a statistically significant amount of change in the parameters used to quantify behavior. The open field test is a helpful assay because it provides additional information on the effects of the compound. Advanced slide, please. In conclusion, the cytotoxicity, rotarod, and open field studies are excellent preclinical assays to eliminate non-optimal drug candidates. In the cytotoxicity assay, LD50 values are calculated based on nonlinear regression. Those that are found to be toxic have low LD50 values and limited cell viability. Non-toxic compounds are further investigated in vivo using the rotarod experiment. The rotarod tests the sensory motor skills of trained mice and is used to evaluate possible adverse CNS effects after compound administration. In conjunction, an open field test is conducted, providing qualitative and quantitative measures of behavior and locomotor activity of the mice after administration of the compounds. The results of these studies are analyzed by ANOVA. Compounds that do not differ significantly from the vehicle control groups are considered good candidates and are further investigated. The acknowledgements are listed on the right, and a special thanks to Dr. Arnold for being in his group, and thank you for your time. Let me know if you have any questions.
Great, thank you, Michelle. I think we have time for 1 or 2 questions from the judges.
Hi, I have a question. I noticed in a couple of the assays that you have, of course, my home phone is ringing now. What happens? I noticed you had the vehicle versus the drug. And I'm wondering, I have a couple things. What is a common vehicle for administering the drug that's being investigated? And also, why not a control with no vehicle at all? For example, in the mouse, activity assay, would it be interesting to see just what the mouse does? For all we know, the vehicle is a drug as well, right?
Yep. Depending on the specific assay that I'm doing, a vehicle for the rotarod, which is the drug that they're going to be in on the open field, we use HPMC with 98% of that, and then a little bit of PEG just to put it into solution. Mm-hmm. We do have data on a mouse without any vehicle as well, but that you don't necessarily need to take every single trial that you do it. We just kind of use that as a basic parameter for all studies. And that we do that every time we get new mice. So.
Okay, thank you.
Any other questions from the judges?
These experiments, how many mice do you typically use? Like what kind of data are you averaging over?
We typically use 16 mice for one compound, which does give you a pretty decent breadth of mice. And, they all have different baseline activity levels and like general levels of coordination. So with that, we provide pretty decent data.
All right, well, thank you, Michelle. All right, next up, we have Leah Pulis from UW-Parkside. Leah?
Thank you. So hello, my name is Leah Pulis, and I'm a student at UW-Parkside. My original research project is entitled EZE-GGPP, a novel potentially bactericidal compound. Next slide, please. Starting with a little background, isoprenoids are a type of hydrocarbon that are found in all living things. Some examples include cholesterol, vitamins, and antioxidants. In bacteria, they also use isoprenoids as carriers to build their cell walls. and bacterial cell walls are important for structural integrity and keeping out environmental toxins. If the bacterial cell wall is compromised, this can lead to cell death. Two bacteria are shown on the slide, E. coli and MTB. E. coli uses UPP as its isominoid carrier, while MTP uses DPP. And an interesting fact about MTB is that its isominoid metabolism is flexible. And what this means is that its enzymes are able to take a variety of different reactants and make a bunch of different products, whereas most enzymes take one reactant and form one product. The DPP biosynthesis pathway of MTB is no different and shows this flexibility. And my research studies these enzymes that are part of the DPP synthesis pathway. It was noticed that when certain enzymes were, so for my research, I don't like to work with active TB. We don't work with active MTB. So instead we insert it into E. coli as a host. And it was noticed that when certain combinations of MTB genes were inserted into E. coli, it caused significant toxicity to the host. And on the table on the right, the three genes and the gene combinations are shown. In white, those are the genes when they were inserted individually into E. coli. And this did not result in decreased cell viability of the E. coli host. Similarly, in yellow, when RV3383C and RV0562 were in conjunction in E. coli, this did not decrease the number of colonies. But when RV1086 and RV3383C or RV0562 were put in conjunction into E. coli, this caused a significant drop in the number of E. coli colonies and the number of E. coli cells. Next slide, please. My hypothesis was that these particular combinations of genes were forming a novel isominoid product that was bactericidal to E. coli. Here I have multiple molecules shown, and they are labeled as on the bottom. And within the parentheses of their labels, those are the stereochemistries or the shapes of the molecules in 3D space, denoted by E and C. On the top, this is the classic pathway of RV0562 and RV3383C, which are GGPP synthases. They take EEFPP and form EEE-GGPP. It's notable that EEFPP and EEE-GGPP are both found in E. coli and MTB, and they don't show any toxicity. On the bottom is my proposed pathway for what's happening. So the GGPP synthesis in conjunction with RV1086, which forms ZEFPP, so that's where the reactant comes from, would make the novel product EZE-GGPP. And this product is novel because the stereochemistry has not been observed before in nature. And also, E. coli does not make ZEFPP or have an enzyme that does that. And so we know that if this product is being made, it's not being made by E. coli. And the difference between EEE and EZE-GGPP is the stereochemistry. Highlighted in the boxes, we see one has a straight chain while the other has a bend in the chain. And this slight change in chemical structure is thought to be causing the E. coli toxicity. Next slide, please. To probe my hypothesis, I took each gene and I expressed them within E. coli, and then I purified the enzymatic proteins. I included them in my enzyme assays and to test out which products are being formed. In my assays, I combined the GGPP synthases, RV0562 and RV3383C, with RV1086 to mimic what I noticed when I noticed that cells were being affected. And then I also combined ZEFPP synthetically with each GGPP synthase to see if this was another way that the product could be formed. From there, I analyzed my assays using gas chromatography, or GC, which separates compounds based on their chemical properties and how well they stick to the column. Next slide, please. To identify my product, I have these gas chromatograms as results. On the left, this shows in black synthetic EEE-GGPP, which can be purchased, and that's the standard. And then to the peak in green is the product result from each GGPP synthase with ZEFPP. Now this product I'm saying is EZE-GGPP, and the difference, like I said, between the two compounds is just the stereochemistry, but they have the same composition, which means that the peak should be at the same place, except that the EZE peak should be slightly left shifted because of the kink in the carbon chain instead of being straight, which is what we see here. To confirm that this product that I'm identifying is EZE-GGPP, I use mass spec, which basically takes the compound, breaks it up into a bunch of little pieces and makes a molecular fingerprint. On the right, we see on the top, the fingerprint of the EZE-GGPP, and on the bottom, the EEE-GGPP. As you can see, both the top and the bottom graphs look nearly identical, which is expected and further confirms that my product is easy EGGPP. Next slide, please. So to conclude, I discovered and identified easy EGGPP, a novel isoprenoid product that is bactericidal to E. coli. It has potential utility as a prodrug and topical antibiotic. My results also showed that I can make this product using the enzymes that I mentioned, as well as synthetic ZEFPP plus the GGPP synthases, which would be cheaper and more effective for large-scale production. My future directions are to determine the antibiotic efficacy and bactericidal mechanism of action of this compound. And currently, I believe this compound is inhibiting E. coli cell wall carrier, UPPS, which I mentioned briefly in the beginning. I'd like to acknowledge the S.C. Johnson Integrated Sciences Laboratory and UW-Parkside for the CNHS, URAP, and SURE fellowships, which made this research possible, as well as my lab mates and my PI, Dr. Mann. Thank you.
Great, thank you, Leah. Any questions from the judges?
I actually have a question. That's interesting. My question, you started to get at the end of your presentation about the mechanism of action, what you think the mechanism of action might be. And you talked about it inhibiting an enzyme that sounds like it's used for building the cell wall. So the cell wall probably will not be intact, or it'll show. How do you determine that? Do you know how you do that kind of measurement to see if it's a cell wall structure that's an issue?
Yeah, for sure. So multiple different bacteria, including E. coli, use UPP as the cell wall carrier. So what we're planning to do is make a lot of the UPP, overexpress it in E. coli, and then apply this compound topically to see the effects. The other bacteria that we're looking at using are other pathogens, a Bacillus species, as well as Staphylococcus aureus. And all three of these, E. coli and the other two I mentioned, react differently to UPPS inhibitors. So when we look at the reactions, if they're all different, that will confirm that this is a UPP inhibitor.
Do you just look at the colony numbers, or do you get down and do any microscopy to actually look at the cell structure?
So we look at colony numbers because without a complete cell wall, the colony won't be intact, and the compound should be inhibiting UPP where it can't build the cell wall at all. It won't, so it won't be just deformed, it'll be completely gone.
Okay, that's interesting. Okay, thank you.
All right, maybe one more quick question.
I have a question. So you said this compound is not commercially available, at least so far, correct?
It's not. This is a novel compound that we identified that hasn't been observed before.
So what kind of scale, using this pathway, do you think you could make this compound?
So we're actually looking at working with an organic chemist who works at UW-Parkside, who has a chemical company, to scale up the production of this compound, because you can buy synthetic ZEFPP and then use the GGPP synthases. This is more of a prodrug than an actual drug because of the ability to scale up just the hydrocarbon. So we're looking at making adjustments to the hydrocarbon and adding other modifying groups.
All right, thank you, Leah.
Thank you.
All right, next up, I'd like to welcome back Megan Bunyer from UW-Platteville. Megan?
Hello again. So my name is Megan Bunyer, and my faculty sponsor for this project is Dr. Kamiko Halfman. So I had expressed my research interest in memory and emotion to Dr. Halfman shortly before the pandemic hit. And when it was just beginning, we decided that we would structure these research interests around events surrounding COVID-19. So we examined accuracy and confidence in memory, and we explored valence of presently felt emotions, valence as in whether that emotion was negative or positive. And then we looked at participants' feelings of control, so how well they felt in control of a situation. Because of the nature of the circumstances and because of the abrupt change in lifestyle and day-to-day living, emotion and sense of control were obviously very relevant to the situation. Next slide. So there is a ton of conflicting information out there about the relationship between memory and emotion. Some researchers have produced results that indicate that greater emotionality, regardless of it being negative or positive emotion, reduces the accuracy of memory, and others have found that emotion improves accuracy of memory. Sense of control, actually. has consistently been shown to have impact on memory in that it reduces accuracy, increases vividness, and increases confidence. The most relevant sources that we could find for reference pertain to the terrorist attacks of 9/11. So 9/11 shares a lot of similarities with COVID-19 in that it was a large-scale, widespread tragic event with tremendous loss, but it does differ in that 9/11 was sudden, it was shocking, and COVID-19 was a slow progression of tremendous loss. So this study may serve to fill the critical gaps that exist in current literature because the formation of memory between these two events is probably going to differ. Flashbulb memory is it's more like flashbulb memory than 9/11 versus COVID-19. We don't really know what form of memory that is. Next slide. So we use several news sources and timelines, not necessarily the one listed. You can see under the methods section, it says US COVID-19 timeline. We used timelines to find and develop questions surrounding the progression of events related to COVID-19. So we measured emotion by asking participants to report their present states of feeling and emotionality. And we measured positive and negative affect using a scale similar to the positive and negative affect schedule, or the PANAS-X by Watson and Clark. To measure sense of control, we used the Lockman and Weaver sense of control scale, which had subscales of perceived constraint and personal mastery. You can see the thumbs up, thumbs down. We asked, that just represents how accurate the responses were. We also asked confidence by asking how confident are you in your responses. Pretty straightforward. For emotion, we asked, to what extent do you feel happy? To what extent do you feel sad? And then you can see the little puppet there at the bottom. What happens in my life is beyond my control. That sort of is a measure of sense of control. Next slide. So results, individuals who had a higher proportion correct or remembered more about the unfolding of the pandemic in spring of 2020 had lower levels of perceived constraint. And individuals who remembered more also had lower levels of negative and positive affect. So interesting, there was also a positive association between negative affect and perceived constraint. So in returning to the hypotheses, we actually hypothesized that more negatively valenced emotions and a lower sense of control would be associated with decreased accuracy of memory. So our results actually confirmed our hypothesis. And a higher proportion of correct responses, if you want to take a look at the picture there with the correlational analyses. Let me just, it's kind of hard to pull it up on my screen here, but you can see as perceived constraint increased, proportion correct decreased, and as negative affect increased, proportion correct decreased. And for the analysis of emotion, we used just a basic word cloud analysis, and that's sort of like a qualitative method. So we found that annoyance actually was a prominent emotion experienced by participants. Next slide. Okay, so in summary, we found that perceived constraint was negatively associated with accuracy of event memory, and both positive and negative affect were negatively associated with accuracy of memory. So although these results are only correlational, this does suggest that higher levels of affect do not enhance memory, but rather diminishes it. So as mentioned earlier, there are many gaps in existing literature regarding the interactions between emotion and event memory, and we have found that the research of others is split, and some have discovered that emotion increases accuracy of event memory. This study serves to add to this body of literature and does so under the unique circumstances of a global pandemic. Next slide. And I just want to take this moment to acknowledge my faculty sponsor, Dr. Kamiko Halfman. Thank you, Dr. Kamiko Halfman.
Great, thank you, Megan. I think we have time for one or two questions from the judges.
I have a question for you, Megan. So you talked about sort of measuring the accuracy of sequence of events. So I'm assuming you were specifically looking at how the pandemic was unfolding in their local or global scale, did you also look at sort of personal memory, like what was going on with the people in their house, and how did you measure the accuracy of some of those things?
Yeah, that's a good question. So we weren't measuring autobiographical memory, or that would be autobiographical memory where a person reflects on their own experiences. We were measuring something more like, because it was knowledge-based, we started out measuring event memory, but our questions were specifically knowledge-based, and we kind of wondered if that might be more a reflection of semantic memory. But yeah, the kind of questions we used for accuracy were just like, when did states implement business closures? What date? So yeah, I don't know if that helps, if that answers your question.
It answers the one part of it. The other part is, so how do you determine the accuracy? Like, are you determining it based on, you know, they said May, but it was really June or whatever? Or are you determining it based on, well, they had the sequence of events correct, they were off, you know, off.
No, so yeah, if they just answered, like if it was May and they answered June, they got it, it was incorrect.
Okay, thank you.
Yeah.
Any other questions from the judges? All right, Liz?
Yeah, I have hopefully a quick question. So this was if I understand correctly, you just asked these students one time, right?
Yep, so you're wondering if like we did a longitudinal thing?
Yeah, I guess that's the word that I'm looking for, yes.
Okay, yeah. So over time, yeah, we just asked them one time, and actually that's something that we would want to look into in the future, is accuracy of memory and presently felt emotions over time, how those change. Thank you for those questions. I really appreciate it.
Great. Well, thank you, Megan. All right, welcome back, everybody. And apologies again for the technical glitches. Smriti Smith sends her regrets. She was not able to join back, but she will be joining our showcase in August. So thanks for your patience there. So I am pleased to be back to announce today's winners of the Student Research and Innovation Showcase. First, another congratulations to all of our presenters today and the campuses that they represented. You all did a phenomenal job. I'd also like to give a big shout out to our faculty mentors who have supported our students and their research projects and really all the efforts there. So thanks very much, everybody. So note on today's prizes, the first place winner will take home a cash prize of $1,000 and the second place prize will take home a cash prize of $500, both courtesy of our prize sponsors at Wharf and Boyle Frederickson. So students, you should be prepared that if your name is called to please turn your video feed and your audio on, give a quick wave. I'd also ask that all award presenters, or excuse me, all award winners to please stick around for a quick screenshot at the very end. So now, the moment we've all been waiting for, I'm pleased to announce today's second place winner is Becca Burell from UW-Oshkosh. Becca, congratulations.
Thank you.
Thanks, Becca. And now for our first place award for the Student Research and Innovation Showcase goes to Jason Martin at UW-La Crosse. Jason, congratulations.
Thank you.
All right, well, congratulations again, everyone. That concludes today's event. On behalf of WiSys, I thank you all for joining us today. We hope you enjoyed the session as well as the Q&A. Remember, the conversations don't have to stop here. If there's anything we can do to help facilitate further discussion, please don't hesitate to reach out. We do have a great lineup of events for the remainder of our virtual series for the Spark Symposium. I encourage you to check out the full listing here at wisys.org. Thanks again, everyone, and have a great evening.